Hi everyone. Today we're going to learn how to graph a quadratic function in vertex form. The equation for the vertex form of a quadratic function is f of x equals a quantity x minus h squared plus k. Just like the absolute value function, we'll be able to use transformations to create the graph from the graph of the parent function y equals x squared. Just like absolute value functions, the graph is going to open upward if the a value is positive, and it's going to open downward if the a value is negative. Also, just like the absolute value function, an a value of 1 will cause the graph shape to be the same, whereas an a value that's greater than 1 will cause a vertical stretch. A value that's less than 1 will cause a vertical compression. Remember that for vertical stretches and compressions, we ignore the positive or negative sign. The parent function for a quadratic is y equals x squared. And we can make a table of values to see what the graph of the parent function looks like. By substituting negative 2 for x, negative 2 squared will be negative 2 times negative 2, which will be positive 4. Negative 1 squared is positive 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. We can plot these coordinates on the graph, and we'll see the shape of a parabola, which looks like the letter U. Notice that this is different from the graph of the absolute value function, which looked like a V. The absolute value function was made up of two straight lines, while a quadratic function is made up of a curve. A lot of other things are very similar to the absolute value function, however. The vertex is still given by h and k, which is the translations, and the axis of symmetry is still given by the vertical line x equals h. Just like the absolute value functions, all quadratic functions are also symmetric about a vertical line. The domain of all quadratic functions is negative infinity to positive infinity, as you can take any number and multiply it by itself. However, the range of a quadratic is not going to be negative infinity to positive infinity. And you can see this because if you look at the table of values for the parent function, when we multiply a negative number by itself, it's also positive, which means that negative numbers will not be in the range of the parent function. Transformations can change the range. So in general, a parabola opening upwards will have a range from the k value to infinity, while a parabola opening downwards will have a range of negative infinity to the k value. So what we'll use to draw the graph will be the transformations from the parent function y equals x squared. Let's do an example. Pause the video for a sec and list the transformations of f of x equals 3 quantity x minus 4 squared minus 5 from the parent function y equals x squared. Hopefully what you listed was a vertical stretch of 3 and translations right 4 and down 5. We should also note that this parabola is going to open right side up because the a value is positive and there is no reflection over the x-axis. Because of the translations, the vertex will be 4, -5. The domain will be negative infinity to positive infinity, and because the parabola is opening upwards, the range will be -5 to positive infinity. Depending on what you're comfortable with, just like before, you can draw the graph either transforming the numerical points from the parent function, or if you're a more visual person, you can take the picture and use the points of the parent function and transform them that way. So, if I want to work from the picture, can start with the original 5 points of y equals x squared. And first I'm going to vertically stretch all the points by 3. So just like before, nothing happens to the vertex at 0, 0 with a vertical stretch. The points that were at 1 on the y-axis will be stretched to 3 on the y-axis, and the points that were at 4 on the y-axis will be stretched to 12 on the y-axis. And again, when I do this, it does not change the x value because it's a vertical stretch. Next, I'll move all the points 4 to the right. And finally, I'll move the points down 5. Once I do that, I can just connect both sides of the U. And we have our parabola. And again, a couple common sense checks. We can see that the parabola is symmetric. We can also see that the parabola is opening upward. And we can also see that in the vertical direction, the parabola got longer. So we do indeed have a vertical stretch. If I'd rather work from the table, we can perform the same transformations. So I'll take all of the x values and I'll add 4 to them to do the translation right 4. Next I'll do the vertical stretch of 3 by multiplying the y values by 3. Again, remember that I do have to follow the order of operations, which means the vertical stretch has to come first, and then the translation down 5 comes afterwards. So finally, I'll take my y values and subtract all of them by 5. And then I can plot those points on my graph, which I'll see will be the same ones that I already have. One other thing I'd like you to note on this graph is the axis of symmetry, which is going to be the line x equals 4. And to double check, I do have symmetry around the line x equals 4 running through the vertex. So hopefully that gives you a good idea of how to do the same thing that we've already done twice, now with a new function, the quadratic function. And now it's time for you to practice some of these on your own.